In this example, we have to find the vertex form of the given quadratic function given here as negative 4x squared plus 16x minus 15. So let's try to do that. So the given function here is actually in the standard form given as, let's say, ax squared plus bx plus c, right? So that's what the given form is. And then since it says that we need to write down, find the vertex form corresponding to this standard form, so what would be the vertex form look like? That would be a times, right, let's say x minus h square of x minus h plus k. So our goal is to change this type of form into that. And so how can we do that? There is a method called method of completing the square, so we're gonna use that. So our goal is to use the method of completing the square, method of completing the square. So this is the method we're gonna use it to transform, let's say, the standard form into the vertex form. So let's try to do it. All right, so we have given here the function as, let's say, r of x is equal to negative 4x squared plus 16x minus 15, right? So this is the given function. On the method of completing the square, the first step we do is we try to group the variable terms. So what are the variable terms that we have on this standard form? We have negative 4x squared, we have right, and then positive 16x. So these are the two terms which involved with the variable. So let's group them. So and then write down them, let's say write down on a parenthesis. So if that is the case, I'm just trying to insert the parenthesis here to say that, okay, I'm just making a group of those variable terms. So this is the first step. The second step is we want to make the coefficient of x square, which is here in this case negative 4. I want to make the coefficient of x square is equal to just 1. How can I do that? Well, if I can take out negative 4 out as a common factor, then the remainder on the first term will just x square, which means the coefficient of x square inside the parenthesis will be just 1, right? And okay, so that is good. But how can I take negative 4 out from this variable term over here, 16x? How can I do that? If I take negative 4 out from 16, what will be the remainder? If I write down here, let's say negative 4x is the remainder, do you think that that is correct? Well, we can double check that, right? Over here, if you distribute by negative 4 times x square will be negative 4x square, negative 4 times negative 4x will be positive 16x. So if they are like a same, right? So once I distribute by the negative 4, if I am getting the previous expression, then it's fine, right? So that is the remainder then. So it's perfectly working. So negative 4, when we take that out, negative 4, if you take that as a common factor out, right, when we do that, x square minus 4x is the remainder on the the variable term. So that's what we will have. Okay, so minus 15. So this is the second step where we are just trying to make the coefficient of x square equal to 1 by taking the leading coefficient, on this case here negative 4, by taking that factor out. Okay, so this is the second step. Now what we need to do here is actually we need to add and subtract a number inside this parenthesis in such a way that we make like some of the terms need to be a kind of perfect square. So how can I do that? So what am I saying here? On this step, we need to add and subtract some number. So let me have a kind of good space over here, and then minus 15. Let me write down in this way so that I can add and subtract some number over here. So what type of number I can add and subtract here so that at least few terms would make a perfect square? So let's try to see here. There is actually a trick. The trick is, now what we need to do is look into the coefficient of the linear term, which in this case is negative 4. Neglect the sign, so the number is just 4, right? Take a half of that. What is the half of 4? 2, right? And now take a square of that. What is the square of that? Square of 2 will be 4. So you get a number, add that and subtract that. Now you may have a two question. One, either that is mathematically correct or not, right? And another question is, why am I doing this? Okay, so first of all, let's answer, is it mathematically correct or not? I think this is straightforward, right? You can always add and subtract the same number. So here, if I combine positive 4 and negative 4, I get 0, and then I am instantly getting the previous expression. So on that case, this expression is valid. So mathematically, I'm not doing something wrong. The question is, why am I doing it? Now if you look into here, now I can answer why am I doing it. If you look into the first three terms of these expression that we have inside the parenthesis, x square minus 4x plus 4, that is actually a perfect square. Well, what is that one? Well, let me write down negative 4, which is the coefficient as it is, and the first three terms, x square minus 4x plus 4, that can be actually written as x minus 2 square of that. So square of x minus 2, which is a perfect square, right? And then that will be actually x square minus 4x plus 4. You don't believe me, you can just try to see what is the square of x minus 2. X square of x minus 2 mean x minus 2 multiply with x minus 2. Now we can use the FOIL. First term multiply with first term, we get x square. X times negative 2 will be negative 2x. Now multiply the inside term, we get again another negative 2x. Multiply the last term, we get positive 4. So now clearly we can see that we get x square minus 4x plus 4. So whatever like this perfect square I have written, that is perfectly working over here, right, for the first few terms, for the first three terms. Now let's write down the remainder here. So over here, what I have here is, when I write down the first three terms on square of x minus 2, then I have negative 4. I need to distribute that to also negative 4 here, because that was remaining inside the parentheses. So when I do that, negative 4 times negative 4 will be positive 16, and then the last term is negative 15. So I can just write down like that. So then we have negative 4 times the square of x minus 2 plus 16 minus 15 is just equal to 1, and that look like a vertex form that we want, right? The vertex form was a times square of x minus h plus k, and that's perfectly the same form we have over here. And that's how we are able to find the vertex form of the given quadratic equation by using the method of completing the square. Alright, so there is only one thing I want you to remind, especially on this step. How do I get that number 4 and negative 4? So that, I mean, how do I choose those numbers so that I make the first three terms as a perfect square? There is a trick I applied, and that always work. What you just need to do is look into the linear term over here, which is the linear term, which is negative 4. Just neglect the sign, and then look into the coefficient over there, that number, just the number, neglecting the sign, and then that is 4 here. Take a half of that number, and then also take a square of that. So that half of 4 is 2, and then I'm again taking the square of that, and then that will give me the number that I need to add and subtract over here. And then to make a perfect square here, okay, I'll write down here square x. I can write down x because there is x square, right? And whatever sign you have over here, use the same sign over here. And whatever is the half of this quantity here, the numbers, half of 4 is 2, so just write down that number over here. So that's how you will be able to perfectly write down that expression.